You and I, we use software every single day. But have you ever stopped to think about how it's actually made? We're about to pull back the curtain on the most important phase of all, the one that happens long before a single line of code is ever written. It's the architect's blueprint.
So why do we always hear these horror stories? Software projects that are months late, millions over budget, or just completely fail to do what they were supposed to do. It's a huge problem and a really, really expensive one. Well, the answer is kind of wild, actually. It's usually not some big, dramatic coding error that happens late in the game. Nope. It's almost always a tiny, almost invisible mistake made right at the very, very beginning.
And this chart, wow, this chart shows you everything. It lays out the cost to fix a mistake based on when you find it. See that first little bar? That's a mistake you catch early, during planning. Cheap, easy. But that exact same mistake, if you don't find it until after the software is out in the world, look at that last bar. The cost just explodes.
All right, so let's put a real number on that. Just how staggering is the cost of getting that initial blueprint wrong?
Okay, get this. The number you need to burn into your brain is 100, 100x. Research has shown it can cost 100 times more to fix a mistake after launch than it does to fix it during that initial planning phase. 100 times. We're not talking about rewriting a little bit of code. We're talking about having to rebuild entire systems from the ground up.
So how in the world do you avoid a 100x mistake? Well, you have to lay a perfect foundation, and it all comes down to one thing: figuring out exactly what you're supposed to be building in the first place.
The legendary software engineer Frederick Brooks absolutely nailed this decades ago. He said that deciding precisely what to build is the hardest part of the entire job. And if you get it wrong, it doesn't just cause a few bugs, it cripples the whole system.
So, okay, how do you actually do this right? Well, it's a process. First, you do a feasibility study. Just ask, can we even build this? And should we? Then, the most crucial step, you gather information by talking to the actual users. You can't just sit in a room and guess what people want. That's a recipe for disaster. After that, you document everything, creating one source of truth. And finally, you double-check it all to make sure nothing got lost in translation.
And here's something that trips people up all the time. Requirements come in two different flavors. You've got your functional requirements, that's the what. What does the system need to do? For example, the system must let users log in. But then you have the non-functional ones. That's the how well, how fast, how secure. Think about it. A login that works but takes 10 seconds and isn't secure, that's not a success, right? It's a failure. You absolutely need both.
Okay, so we know what we're building. Now we have to figure out the internal structure. It's the floor plan for all the information, all the data that the software is going to use.
And the key tool for drawing up that floor plan is called an Entity Relationship Diagram, or ERD for short. Just think of it as a simple visual map of all the data. But here's the magic of it. It's not just for the techies. It creates a common language so that everyone, and I mean everyone, from the CEO to the newest developer, is looking at the same map.
And believe it or not, it's all built from just 3 super simple ideas. First, you have entities. These are just the nouns of your system. The big things like customer or product. Then you have attributes, which are the details about those things, like a customer name or a product price. And finally, you have relationships, which just show how they're all connected, like how one customer can have many orders. That's it.
All right, so we've got the floor plan for the data figured out, but a building is not much good if you don't know how people are going to move through it, right? So now we need to map out how the system actually behaves.
And how do we do that? Well, we tell stories. No, seriously. In the world of software planning, these stories are called use cases. And each one is just a simple, step-by-step story about how a user interacts with the system to get one specific thing done.
And a perfect example that we all know is just getting cash from an ATM. The story goes like this, right? A customer inserts a card. They enter their PIN. They pick an amount. The system gives them cash. They take their stuff. Simple. By writing out these little stories for every single thing the system needs to do, we get this incredibly clear picture of how it's all supposed to work.
But sometimes, it's not about what a user does. It's about how a single thing in the system changes over its lifetime. For that, we use something called a state diagram. It's basically a map of the life of an object, all the different states it can be in, and what events push it from one state to the next.
Like, think about a person's marital status. You start in the state of single, then an event happens, getting married, and boom,
you transition to the state of married. It's a really clean, simple way to track these kinds of changes.
And one last diagram to cover, the activity diagram. So if a state diagram is about the life of one specific thing, an activity diagram is like a flowchart for a whole process. It shows the flow of actions and all the decision points along the way.
So here's the dead simple way to keep them straight. State diagrams are about the state of being. Is an order pending or shipped? Activity diagrams, on the other hand, they're all about the flow of doing. First you do this, then if yes, you go here, if no, you go there.
Okay, let's step back for a second and bring this all home. Why on earth do we go through all this trouble, all these diagrams and documents, before writing a single line of code? It really all comes down to the power of a shared blueprint.
And this right here might be the single most important takeaway from all of this. These blueprints, these models, they're not really for the computer. They're for us. They're for people. They're communication tools designed to make sure that everybody, the users, the designers, the managers, is on the exact same page, building the exact same thing.
So I want to leave you with a final question. This way of thinking, really understanding the needs, defining the behavior, modeling the structure, it's incredibly powerful for building software for sure. But where else in your life could you use it? Planning a big event? Launching a new business? Organizing a complicated project? How can you use this architect's mindset to build better things? Not just with code, but anywhere?